So let's get started. Welcome and thanks for joining our June edition of our Connect Over Coffee series. I am your host today, Steve Tu. Hopefully you've got your coffee in hand, ready to hear our presenters today. Jason Bordujenko, Global Head of Solution Architecture at Megaport, and together with our special guest from AWS, Nikola Cuca, Hybrid GTM Specialist, and Sumit Menaria, Senior Solution Architect, also from AWS. In this session, we will run through AWS local zones and regions and details about the new Auckland Direct Connect on-ramps, the benefit and the value it brings from the AWS and Megaport Alliance, and what it means for Australia, New Zealand, and global enterprise organization. And Jason will do a live demo to showcase the process used to connect to AWS local zones from Megaport. A bit of the housekeeping stuff. This session is being recorded and the video will be made available on demand after around 2 to 3 days. And if you have any questions during the session, please use the Q&A function down below. And one of our panelists will answer them via the Q&A function or pass to our presenters to answer live. With that, I will hand over the mic to Nikola and Sumit to give us an overview of AWS local zones. Over to you, Nikola.
Hello, everyone, and thank you for joining a session today. I am a go-to-market specialist looking after the AWS hybrid services, which include local zones, outposts, and Snow Edge, a family product across Australia and New Zealand. Today, I will touch base over the three questions. One is, what are some of the challenges that AWS local zones can help customers with? High-level overview of what local zones are. And the third one is, where do we have local zones at the moment across Australia and New Zealand? So based on the customer feedback and working backwards session and the comments we have received, customer challenges can be grouped into the three different categories. One would be a low latency workloads. And what do I mean by that is, these are the workloads that need to remain on-prem or the workloads that need to run closer to the customer source of the data, and where a distance to the nearby region is too far and the latency is not acceptable. The second category of the challenges that customers have shared with us is the modernization initiatives. So sometimes it's too difficult to do a lift and shift from on-prem to the region, and how AWS local zones can help is that there can be that intermediate step in two-step migration. And the third challenge is really can be grouped into the data residency category. And what do I mean by that is that the customers would love to deploy the workloads globally where we don't have the presence of the region, or do they have a legal requirement that the data and workloads have to remain in the specific geo allocations? So solutions today which customers have, it can be boiled down to the self-managed data centers, which are proven to be complex and costly to manage. In addition, there is a whole lot of the interoperability testing that needs to be done across the various flavors of the hardware and the software across the data centers that have been deployed in the different geographic allocations. So what have customers have asked us for? He said, it would be great if we can have the same infrastructure and same reliable and high performing infrastructure as the region closer to us, closer to our data centers, closer to the source of the customer data. We would love to use the same operational consistency and use the same API. Local zones, it is the same hardware that we use in the regions and the same tools and automation and our deployments and security controls can be extended easily from the region onto the local zones. And more importantly, what we are seeing across the ANZ is that the customers are really keen to have the same pace of innovation that is happening in the cloud with new features and functionalities closer to them. What AWS local zones are? Local zones are type of the infrastructure that we have launched to address a hybrid and cloud edge customer needs. Local zones, they bring a compute, storage, networking, and databases closer to the customer on-prem data center and source of the customer data. With local zones, you will extend AWS region or the cloud closer to you. AWS local zones, they are connected by the AWS backbone, in our case, across Australia and New Zealand to the Sydney region. The good thing about local zones is that it is AWS deployed and managed infrastructure. It is following pay-as-you-go model, and you can have access to the AWS core services from a compute, storage, networking, and databases. Where do we have local zones? This year we have launched 2 local zones. One is in the Perth, the other one is in the Auckland, New Zealand, and we have plans in the FY24 to launch the local zone in Brisbane. Now, I will pass on to this, Sumit to talk a little bit about AWS local zone architecture and what does it mean and how does it work.
Thanks, Nick. So with local zones, how local zones are presented to the customer is basically they are able to use their existing VPC and able to create subnets in that local zone specified after opting in. So the same constructs of public-private subnets, maybe in the region you have presence across multiple availability zones with public and private subnets. You can create the same public and private subnets in local zones as well. You can have your applications run and make use of those basic VPC constructs like route tables, security groups, network ACLs, which are you're getting the same experience which you do in the region. Now, what it does present you is that with the selected set of compute and storage services, you are also being able to use all the full set of features and services based in the region. For example, S3, RDS, or any other services which are running in the region using the backbone or connectivity between Auckland or the local zone and the parent's region. Now, the benefit of when we talk about latency is achieved through the internet gateway, which you see on the right, and the direct connect gateway. Now, these are region-based constructs, but what they really help is, for example, internet gateway. Any resource with public IP addresses launched in a local zone will be routed via the local internet pairing or Amazon border pairing from a local zone towards the local ISPs. So the traffic for the users who are trying to reach out to your application in a local zone, the traffic will not hairpin all the way through the region, but instead it will directly egress and egress through the local connectivity itself. With regards to direct connect as well, the local pop location connected or nearby the local zones will see the target subnet. So based on if the target subnet is based in local zone or if it's in the region, the traffic will be routed locally rather than happening through the region. And that's the advantage of really getting into the or providing the low latency or single digit millisecond latency to your clients or for your applications. And with that, what we have seen is basically a wide variety of use cases which customers have come up with, and not just latency based, but location based as well. And I'll dive deep into these two kind of categories. In the latency bracket, we have seen customers using local zones with the use cases involving two kind of approaches. One is basically distributed edge, and the other is hybrid edge. When I say distributed edge, is customers build their applications once, or build their workload once, and they deploy it at whatever location they require as such. And this can be, for example, users like gaming customers who are deploying it across multiple locations to be able to give the appropriate experience to their end users based on where they are living or where they are accessing the application from. Or it can be the hybrid edge deployment kind of situation when I'm talking about customers like Netflix or Baptist Health who are considering local zones as an extension of their corporate assets. So imagine customers what you have then is basically LA's local zones. When it was first live, and Netflix was using that to host their content creation platform with that, and all the artists being able to access that platform in LA's local zone itself with low latency. So, and a second category, what we see is the location-based, which is where customers who want to expand to new markets, but they are bound by those regulations that the workload needs to reside or the data needs to reside in a particular geography or a council or a particular state. In that case, it becomes of more importance to be able to have that presence where AWS region is not present in a country. So local zones help you run their workload within the country, even if the AWS region is not present. Another category which we have seen is from migration and modernization perspective, where customers are also considering cloud or local zones as maybe a cloud burst or a DR site as an effort to slowly lift and shift towards the cloud, be it containerizing the workloads or being considering as an extension of their corporate assets itself. That's the typical use case of local zones, which we have seen. And talking about extension of corporate assets, one of the important things comes in mind is basically customer using that dedicated direct connect line from the on-prem towards local zone itself. And we have seen many use cases started with Auckland itself as well. And that's where I'll get Jason to jump in and talk about how Megaport can help our customers.
Thank you, Sumit, and thank you, Nikola. That's a great introduction and really appreciate AWS involvement in this. And there's been some questions coming in the chat. There is a Q&A function in Zoom. Could I ask if you could please put your questions in that and we can actually push the answers to everyone instead of individually answering them. But I think Steve's been doing a great job of tackling some of those. The main one that's come up is obviously the local zone in Auckland live? Yes, absolutely. So that's distinct from the region, which has been announced, but not full region available quite now. I'll be covering the Megaport perspective of that and how you can architect and connect to the local zone in Auckland. But also for this webinar, it's ideally suited around New Zealand. It's important to note that we've had local zone capability in Perth, so well across the other side of the West Island for some time. And all of the principles that we're using and talking about today will be relevant in Perth as well. So for the Megaport recap, I will talk about our network and where that sits in Australia and New Zealand. Obviously, we have presence outside of that in Asia Pacific. But we have 11 different data centres in Brisbane, 26 through Sydney and Canberra, 12 in Melbourne, Adelaide is 5. And notice with Perth, and now we're talking about New Zealand with North Island. So for Perth, we can collect customers that are connecting and want direct connect from 6 different data centres. And in the North Island through Auckland and Wellington, there's actually 16 data centres. So if we take the one where direct connect is available natively from AWS, out of that, there's 15 other data centers where we can actually provide that service. Now, there's a combination here that we want to talk about today, which is obviously which of the backbones are being used. So connecting to direct connect in the location that is available in New Zealand, which is in Auckland now, can obviously benefit you from the single digit millisecond latency. And that's really what I think some of the questions that I've seen come through are, how do I architect for that? How do I deploy workloads which are still in AP Southeast 2, which is Sydney, but obviously utilizing the local zone and some of those components that are available in Auckland? It is possible to use a combination of the AWS and the Megaport backbones. We'll talk about the Megaport side. So I'll highlighting some of the Megaport partner competencies and the service validations that we have with AWS. And we've been doing Direct Connect for some time. Megaport's just hit the 10-year anniversary as a company, and obviously headquartered here where I am in Brisbane. But that certainly has been a great representation across to New Zealand. And the circuits that we use, although they are connecting to Direct Connect, we call virtual cross connects or VXCs. So one of VXC, whether that's, let's say, from Wellington through to the Direct Connect on-ramp in Auckland, which are actually what I'll be showing you in the demo later today, or in fact, all of the way through to Sydney to build out resilience and diversity. All of those are path protected across multiple subsea or fiber system paths. I'll do a quick refresher into some of the topics. I know a few of you have probably delved into these previously. Hosted connection and hosted VIF or virtual interface. These are the AWS Direct Connect topics. Hosted connection is the only type of connection that is available within Auckland at this point in time, but we still do maintain hosted VIF for some customers. Over on the right-hand side, we can actually see the depth of the Megaport network where it meets the AWS edge locations. So globally, we have 42 ports that are enabled for hosted VIF and 98 for hosted connection. And really going through that combination, there's a slightly higher per hourly fee that is charged by Megaport, and there is a port hourly fee based on the bandwidth through Amazon, but that does give you uncontended or one-to-one bandwidth, which is important. Speed increments are now supported from 50 megabits per second to 10 gigabits per second. That is a fixed speed tier. Once it's deployed on hosted connection, you can't move that up or down. But what it does give you, you'll note in the hosted connection port counts, is for every site where we actually bring those on-ramps, as we call them, the meeting points to Direct Connect live, the Megaport side will have what's called a red and a blue zone. So those are our diversity zones, and they actually are completely separately routed onto different infrastructure in different parts of the data center on both the Megaport and the AWS side. They can be echoed in most locations where we have diversity on your side as well. So whether you take one or multiple ports with us, it is possible to build very resilient architectures. Hosted VIF is a more limited offering. It's more for test and dev workloads. It certainly does work with the private VIF type that we'll be talking about later. It does allow you to have that flexibility in the VXC speed, but the diversity is actually by utilizing multiple locations across our network or multiple on-ramps. So in talking a little bit deeper about how we do build an architect for diversity, what we're talking about today is obviously the local zone, which is homed to a particular region. And I'm pointing out here the on-ramp locations in terms of the data centers where we're actually meeting the AWS network. So at the moment with the AP Southeast 2 or the Sydney region, within Sydney itself, that's available from Equinix Global Switch and NextDC facilities. So this is again, the benefit of the Megaport network is we're not tied to a single data center provider. It allows us to use all of those different facilities as targets for that Direct Connect on-ramp. Also, that AP Southeast 2 region is available, as I mentioned, in Perth, so handing off to AWS in that location, even handing off to the Sydney region within Melbourne, and as we're talking about today, handing off to the AWS network within Auckland and then utilising the AWS backbone. But obviously Perth and Auckland, as mentioned, can then take advantage of that lower latency local performant workloads within the local zones. Do note, however, at the start of this year, there was a new region launched, and that is discrete within Melbourne. So AP Southeast 4 is also available. Customers in New Zealand can utilise that as well using our backbone. It doesn't have a local zone that's tied within Auckland or Perth in this case. So Melbourne is a standalone region in and of itself. What that does allow you to do is actually build multi-region resilience as well. So that is a capability that some customers are taking advantage of. Over on the right-hand side, you'll see a couple of diagrams there from a customer perspective where they meet us at a Megaport-enabled data center. They can actually connect one or more, and I've got two separate Direct Connect connections here. These are using the hosted connection, and you'll note that they're using that red and blue diversity zone components that we're talking about. So from a single port, I can build multiple of those VXCs, or to go to the diagram below, it's actually possible to split that out. If my data center where I'm connecting from supports the red and blue diversity, I can actually have those two ports within the same data center, two separate cross connects, completely separate paths, both outside of that data center and then into cloud. It is also possible for customers who meet us in more than one location, whether that's in the same geographical area or split across multiple, to actually take those ports and consider them diverse across physically separate data centers as well. To look at some of the source locations, we spoke about the destination locations or the on-ramps. Building for diversity, I'm just listing some of the data center providers here. A lot of these actually have multiple sites, multiple parts of presence for us. The reason I list this is obviously most customers that are joining us today, and thanks for those that are tuning in for the webinar, hopefully some great questions around this later. Most of them will know the data center provider that they're either working with or have a circuit that's connecting to on a local loop provider. So what we're looking at in New Zealand, and particularly homing in on that, Chorus, Datacom, DataVault, IBM, Plan B, Rivera, Spark, Data Center 220 Queen, Vocus, and Extreme Data Center. So they're spread throughout Auckland, Hamilton, and Wellington. And we're actually going to use, as I said, a Wellington data center in the demo later on. I'll touch on some of the components that Megaport bring. And obviously on the right-hand side, we're looking at the Direct Connect on-ramp within Auckland, and as we call it, where it meets the AWS edge or their on-ramp. It is possible to build across a VXC one of choosing a public VIF that is public IP addressing, a private VIF, or a transit VIF. And I do call out there that one less than 1 gigabit per second, that was a previous limitation for transit VIFs, where only 1 gigabit per second or above could actually utilize that to target a transit gateway. We will be talking about in some of the examples coming up, using a transit gateway is great. There are some benefits that I'll cover in a slide to come, but it does restrict because at the moment, the capability of the transit gateway is built within the region itself. So customers that are using transit gateway actually need to ship that traffic effectively from Auckland or Perth, as it may be, across to the home region to hit the transit gateway. And then if they were actually using a local zone, it would be hairpinning back across the Tasman or the Nullarbor, as the case may be. So the reason for the little red arrow there is it is possible, having multiple VXCs and considering that diversity we're talking about, to build a private VIF as well as that transit VIF. So taking advantage of both of those components. On the left-hand side there, we'll see a bit of a diagram or a representation where a customer meets us in New Zealand. It is possible to actually have a hosted connection all the way over to Sydney and still maintain some of that capability to burst up or burst down. The other benefit is for the high resilient workloads built on AWS with Direct Connect, being able to use multiple on-ramp locations is actually key to getting that diversity fully built out. So we do have a component that I'll talk about briefly today called MCR, and I'll get back to that in a future slide. Before I do though, a little bit of interactivity to keep everyone happy and awake. We do have a bit of a poll. I think, Steve, if you could kick that off for me, covering some of those components that we've spoken about today. So this is if your organization is currently using Direct Connect, are you doing so on a dedicated connection? And this could be Sydney, it could be Melbourne, it could be even Auckland if you've got that live today, or are you doing so with a hosted connection? So what we're talking about through a provider such as Megaport. If not, you don't have either of those today. If you're planning to use that in the future, please indicate that. Or no, I don't have one. Just interested to turn up and see what you've got to talk about today. By the way, we can't vote, these panelists. So give that a minute or so, and as those roll in, we'll kick forward. What I'll go on and talk about in the interim is the MCR, or the Megaport Cloud Router. So this is a component that it's not a gateway in the AWS construct, but it provides a routing component on our network. On the Megaport data plane and in those locations, you can see across New Zealand, Australia, East and West coasts as well. You don't actually need a data center presence in those locations, and you don't actually need to bring a router license. Megaport will handle the complexity of that routing and do so through our portal. It is available on month-to-month terms, or you can put a longer-term duration on that. And really, the reason we're talking about MCR in the general sense is in that diagram before, for a New Zealand customer connecting to Direct Connect in Auckland, how to build that diversity through to Sydney. Obviously, I spoke about the red and the blue diversity zone. That's still within a single data center location in Auckland. So a customer that wants to take advantage of that trans-Tasman capacity with a VXC will often look to build a diverse service all the way into AP Southeast 2, the Sydney region itself. The downside, as I mentioned, with hosted connection, it's great that you get the uncontended bandwidth, but it does set you to that particular speed tier that's chosen. So if you choose 1 gigabit per second, the trans-Tasman element will need to be stuck at that. But we do have customers that are actually performing more advanced constructs in that they're building an MCR with a total throughput, and there's 4 different speed tiers available on the Megaport side, they're building an MCR within Sydney, and then from New Zealand, or the vice versa, as I mentioned, from Perth into the East Coast, those VXCs are actually not the hosted connection itself. They're a private connection between the customer co-located port where they are meeting the Megaport network and the MCR, and those speeds can be flexed up or down as needed within about a minute. So I think I've covered the MCR. Steve, do you want to close off that poll and show results? I'll grab that. Thank you. That's good to see. Bit of a mix. Mostly with hosted connection today, and some planning, some just interested to come along and meet us today. So I really appreciate that you've been filling those out. It's pretty good completion. That's all for the interactivity, unless you have Q&A. What we will talk about, I think, is tackling some of those questions on optimizing for latency and in terms of supporting the local zone. So we've covered the different connection types. We've covered the hosted VIF and hosted connection, and in fact, the on-ramps, it's a pretty good deep dive for now. This is actually an article that's based on a blog that is on the Megaport website, and I will share a link at the end of this presentation, or we'll make the presentation available for download after. And it's talking about the different gateway types. So we're no longer talking about the Megaport side, we're talking now on the AWS side, VGW, DGW, or Direct Connect Gateway, and TGW as Transit Gateway. There's a good table here that actually summarizes some of the benefits, and on the right-hand side, under that Direct Connect heading, you'll actually see, and you'll see this when we come to the demo shortly, on the AWS console, Direct Connect gateways, virtual private gateways, transit gateways are all represented under that menu as well. So VGW is the most basic. It allows the aggregation of multiple VPCs with a single Direct Connect virtual interface, or VIF. Stepping up from there, the DXGW, or Direct Connect Gateway, that builds upon that capability, but it can allow multi-region capability as well. The biggest limitation between that and some of the questions that were asked is actually what is called transitive routing. So that is, I want to exchange routes from one VPC, let's say in one region, through that gateway into another region. And that was not something that the Direct Connect Gateway natively supported. So what we saw is a bit of a change, a bit of a shift to utilize a transit gateway, which is in fact performing slightly more advanced capability in the back end and provides that transitive routing support. The differentiation here is that exists within the region and cannot be supported within the local zone. So if you are using a transit gateway, it's certainly possible to do so from Auckland, and you connect using a hosted connection with a transit VIF to that transit gateway. You can't actually take advantage and use the local zone that's within that particular area. So again, Auckland or Perth in this case. But we can add additional VIFs, and again, whether that is a hosted VIF or hosted connection, we can support those multiple types. So that's what we'll be talking about. And I might invite Sumit to join me on these as well. So I'll cover the right-hand side, which is the Megaport component. And this is looking at a customer that's connecting to us at a Megaport-enabled data center. They obviously have a physical cross-connect to us at that site, or multiple, or an on-premise connection through a local loop. So once that's connected, and again, I've listed out the New Zealand sites there and the architecture as well for West Australia customers that are joining us, it is possible across that connection, that private VIF in this case, to use the DX gateway. Sumit, I'll throw to you there. Do you want to explain this slide? Because we've got another slide as well that we'll get you to step to and talk about.
Yeah, so basically one of the patterns which we see with customers is using Direct Connect Gateway and their private VIFs is basically extending the existing VPC from the region and creating a subnet in the local zone. With that, depending upon what kind of Direct Connect colocation you are in, Direct Connect will route the traffic towards the target subnet based on the nearest path possible. So basically, if it's in local zone in Auckland, then Direct Connect colocation in Auckland is going to route the traffic locally towards Auckland. If the subnet is in region, then the traffic is going to go from the Direct Connect colocation through AWS backbone. That is what AWS is going to do it for you, towards AWS region and specific subnets over there. So customers can create multiple VPCs, extend those subnets towards local zones, connect the VGWs of the VPCs to Direct Connect Gateway, and have that single private VIFs. Of course, that's a single point of failure as well. So we might plan for multiple ones as well. But single private VIF does enable you to reach out to all the VPCs be it local zones or availability zones in the region. If you talk about another pattern which we see is basically transit WIF, and which what we have seen is basically customers having multiple VPCs. If this could be requiring maybe multi-account structure, different kind of workloads, dev, test environments, etc., like that. And that's where customers do use transit WIFs to be able to connect them using a transit gateway, get the VPCs to talk to each other, as well as get the VPCs to talk to the on-prem environment. Now, transit gateway is a region-based construct. So, which means that if you have a transit WIF connecting to your local zones based subnet or VPC, traffic will be hairpinned to the region. It does not work. Technically, it works. It's just that you do not benefit from the low latency which you're expecting out of a local zone. So what we recommend in that case is split your workloads into local zones and the region. So the VPCs for the region, in this case, Sydney region, will be using a transit WIF, continue to use that. For the workload based in local zone, you can create a private WIF and connect locally via the particular co-location. So the traffic for the specific destination is routed depending upon if it is transit WIF for the region-based or private WIF for the local zone-based VPCs.
Thank you, Sumit. Do appreciate that. And I think the best way to illustrate some of those is to come to a demo. So we're at 1/2 the hour, and we will leave some time for questions. Thanks for those that are passing them through, and thanks to the team that are typing furiously as I talk through it. This is my last wordy slide, and really coming to planning for resilience. So there is a Direct Connect resiliency toolkit. I haven't linked it for this presentation. If you get the slides or you search for that, you'll certainly get the capability. Creating at least 2 direct connections for a production workload is absolutely recommended. And for customers in New Zealand, looking at doing so to both the Auckland on-ramp, which has that red and blue zone diversity, as well as through to Sydney, taking advantage of both of those will give you the capability, whether or not you're actually utilizing local zone, it will give you that resiliency across multiple path locations as well as multiple sites. It is important to look at the VPN or security aspects of it, because if you're using a site-to-site VPN, again, like Transit Gateway, that's a construct that resides within the region, but the internally hosted one. So you'll be actually passing that traffic through the parent AWS region, even if you're handing it off within Auckland. So it won't be able to take advantage of the local zone using a site-to-site VPN, as mentioned. So the recommendations that we're giving to customers are to look at TLS or other layer 7 encryption. Obviously should be standard by default. When connecting directly to the local zone, it's still possible to use that in concert with the VPN construct. But just bear in mind, like Transit Gateway, as I mentioned, that it might be routing that through and you won't be able to take advantage of that lower latency. The Direct Connect pricing itself doesn't change when connecting to subnets placed in local zones. In terms of the compute, there are, on the AWS side, different pricing structures to run a compute workload in Sydney region as distinct from the local zone that's attached to that. And probably the last piece, this is actually pulling from AWS specific guidance as linked at the top. There's a lot of questions that the Megaport team get, and we're talking with some of the solution architecture members in my team, that a lot of the reference architectures say that to connect, it is required to have more than one VIF, which means a dedicated connection, or it was only supported going directly through AWS. And what I want to show you in the demo to follow is it is possible to do so across these hosted connection models and even to multiple locations using the Megaport backbone. So it's not the case that you do need to acquire a dedicated connection. It is something that we can obviously and quite willing to talk about if there are requirements. So if you do need to have a dedicated connection, but you're not in the facility where Direct Connect is offered natively within Auckland, or in fact any of those other data centers for on-ramps that I mentioned, please get in touch with us. We have methods to actually facilitate that. And when you have a dedicated connection, it's possible to actually spin up to 50 private VIFs and 1 transit VIF per connection. You still need to think about those constructs of resilience and, of course, the routing patterns, which is why it's a bit more advanced than what we'll be able to get into today. I will pause on the Q&A. We'll come back to that, but let's see how well the demo gods have been prepared for today. All right, so I'm just going to change slide share now and come back into the Megaport portal. Hopefully this is familiar to a lot of you, but it's great to have those poll results, and thanks for completing that. I've actually created an MCR, and this one is in Auckland and connected a couple of AWS VIFs. So they're both connecting through to Auckland at this stage. And if I step across to the AWS console, you'll see those that are actually reflected here as well. But I can see a transit VIF that's currently connected within Auckland. Let's click on that, and we can see the transit VIF is sitting there, and also one that has been connected but does not have a private VIF connected right now. So this will actually building out the construct that we want to talk through. And I'll just go into that briefly as an overview before we actually step into this. What I'll be doing is connecting from a Megaport enabled data center. I'll actually order a port and show that from the perspective of one that is in Wellington. And you can see in the dotted red box below, we'll actually be connecting alongside that transit VIF that's going off to the Sydney region. We'll be connecting to a direct connect gateway that will actually land into the local zone. So some of the questions that have been coming through about what does this look like when the region goes live, you'll get an idea for the flexibility to actually change that from homes to AP Southeast 2 to the region that will be natively standing up in Auckland as well. So before we go too much further, what I'm going to do is look at the process for creating a port. So I know a lot of you on the call have probably stepped through this already, but if we step into New Zealand, I mentioned there's about 15 different data center locations, and we can see them there listed by data center provider. And in this case, I'm going to look at Wellington. So I can simply type Wellington there, or some details about the address that I know, and I can see the Datacom Rivera and Extreme data center sites. We're able to select a speed, and that's matching the customer premises equipment, or in fact, the fiber that may be connecting in off the street. So a 110, and in some cases, 100 gigabit per second port, and we'll call that webinar NZ. And we'll simply make that as a single port that's available at that data center. So it's quite a simple process of actually stepping through. Now, before I go on, what I want to do is add an AWS connection to this. And by clicking on that plus connection and looking at the AWS tab, we can see that we're given the choice of connecting hosted VIF or hosted connection. As mentioned, if I select hosted connection, I'm going to be able to focus on and target New Zealand. I've already got those connections live in this case. So we can see that there's a red zone at Datacom and a blue zone at Datacom in Auckland. So it is possible to connect from this port all the way through to those sites across the Megaport backbone. So that's north to south of the North Island, or it's also possible to connect all the way to the regions within Australia. And you can see by selecting Australia that we're even given an option for Melbourne within AP Southeast 4. I'm going to be choosing one of the sites that we use in Sydney. So we'll choose Global Switch West for this example. And it's possible just to say webinar test. And this is where I choose the rate limit. So as mentioned, anywhere from 50 megabits per second supported up to 10 gigabits per second. The only data that I need to actually provide this from the AWS side is my account ID. So I can simply provide that and paste that in that I grabbed from the AWS connection, and I can add that to my order. That will stand up both the port and the VXC or the VLAN. So I should see that come through in a couple of minutes' time. Doing it all live, isn't it great to actually show these live? So, all right, let's come back to the connection screen. So coming back to AWS, I mentioned before that it is possible to see the gateway types. So if we actually were to step through, and there are a lot in this demo account that we utilize, direct connect gateways, virtual private gateways, and transit gateways. And for the purposes here, I've actually created a couple of gateways. These are direct connect gateways, and this will allow me to use the existing VIF that I have, but actually stand one up through New Zealand, that it will land into that local zone. So with one that I've already created, as mentioned, the transit VIF will be utilizing the transit gateway that's resident in Sydney. But for the process of connecting a standard private VIF, once I've stood the hosted connection up, I can simply come in here to create virtual interface. I won't be choosing the transit or the public type. I'll be choosing private and give it a name. So webinar JB, it's private. It will be automatically using the connection that I have chosen. So in this case, it's homes to AP Southeast 2, but in the Auckland facility. So that's already chosen for me. I'm able to use another AWS account as the VIF owner. I'm going to use mine in this case, the one we showed earlier. And here's where I'm able to choose the connection type. So we can actually utilize direct connect gateway, which then connects to a VGW or natively straight through to a VGW. Just for the purposes of the demo, I have a gateway that I showed you earlier, the webinar JB, and we're going to give it an AS number, which we can pretty much pick from that private set of ranges. So I'll simply say create virtual interface, and that will stand that up. We can see that's in pending state. That in a matter of minutes will allow me to stand up that connection and route natively into that New Zealand local zone, because it is attached within Auckland. For the connections that we've shown before, and these are the ones that I ordered against that port in Wellington, I've actually connected that through to a different on-ramp location, which is in Sydney. And you can see that reflected here, that in real time, I'm going to assume that the port has been physically connected to, that is sitting in an ordering state, and it is against the global switch SY6 presence within Sydney. So again, it's another AWS on-ramp location. It provides that red and blue diversity, but in this case, we're utilizing the Megaport backbone across the Tasman, multiple subsea fiber systems that are available and path protected. So all I need to do to accept that is to go into that connection, and because I've used that account ID, it's going to say, you know, is this you? Is this really the right connection? Before I stand that up, yes, that's me. I did request it. If anyone else has used my account ID, I'll see that at that point, but I simply get to confirm that. So that will then make that VIF stand up live, sorry, the VXC stand up live, and then I can order the VIF in the next step, as I just did. So I won't do that a second time. But in terms of the connections there, the one that I've previously connected, you'll see that will move from a pending state, and in a minute or so it will become available. So that will actually stand that up live. And this connection, I haven't actually configured my side yet. It's currently down, but that VIF is now ready to accept those connections across. And I'm able to build that architecture as described here. So what we've done, just to over review and do a recap on it, from a Megaport enabled data center. So as we mentioned, for the purposes of local zones, ideally they would be where we're seeing a local zone represented. So at the moment, Auckland or Perth. And as the AWS team have mentioned, it's been announced, but not yet live within Brisbane. A Megaport enabled data center that isn't actually natively Direct Connect enabled itself, or even if it is possible to take advantage of those VIFs. So the VXC is the Megaport name, the virtual interface is the AWS name. And in the demonstration that we just had, there was already an existing transit VIF that's a cross-hosted connection landing into the region natively, so Sydney in this case, and using the same on-ramp in this example, the Direct Connect on-ramp in Auckland, we can stand up through that single port in this customer example, another virtual cross-connect VXC, and land using a private VIF into either the Direct Connect gateway or the VGW. And that will allow us to route that traffic, as you've seen there, to the local zone. And what we would typically expect to see within, say, the Auckland metro area is about 4 or 5 milliseconds of latency, rather than 20 to 30 milliseconds heading off to Sydney. So it does give you a pretty good, capable path into utilizing those transit gateway connections. So that is pretty much it for the demo. Thankfully, the demo gods have smiled on us today, but we will move to Q&A. I'll go to the final slide just to allow you to get a couple of quick QR codes if you'd like to, as we move to question and answer. And again, thank you to Nikola and Sumit. I think you'll be joining me for the Q&A and the verbal side. You can book a meeting with me, or I can work on getting one of the solution architecture team in touch if anything you have seen has piqued your interest, or you're looking at bringing some of your connections today to utilize the on-ramp within Auckland. And as I mentioned, that slide that we sort of skipped over that had a lot of detail in the gateway types, that's available as a blog on our website. So if you'd like to dive a little deeper into that, that second link is the one that you're looking for. So let me come back to the questions. We'll open those up. Please feel free to pass them into the Q&A. We'll probably do them now, talk through them. There was a question from Manish on hosting a file server in local zone, and is that part of the VPC in the Sydney region? So yes, it is possible. If you're currently utilizing those services within the region, it's possible to simply set up a subnet within your VPC, and when you're doing so, to attach that to the local zone, as I mentioned, whether that's Perth or Auckland, and that compute will then be placed local. It's not all compute types, it is a large range of compute types, but then that lets you utilize the Direct Connect, as we've shown today, to actually reduce that latency. Other questions that have come through are in regards to connecting already through to Sydney, but looking at cost benefits in moving them to Auckland. So talking on the Megaport side, there is a per megabit per second cost that we apply across the Tasman. Obviously, if you're connecting to the Datacom site in Auckland, if you're connecting from a New Zealand location, you're not going to be paying that Trans-Tasman cost. You would be paying for the Direct Connect port hourly cost within New Zealand. There are some costs on the AWS side about routing that traffic back into Sydney, but it depends on whether you're using that compute capability natively in New Zealand or looking at it all coming across to Australia in that case. Any other questions? I think Nikola, Sumit, did you have any that you wanted to cover off? I think there was a question there on what does the Trans-Tasman path look like on the AWS backbone, and I don't think you can share capacities of providers, but can you give us a bit more detail on the AWS components of building from Auckland through into Sydney?
Yeah, so from Auckland to Sydney, we have and basically that is part of the AWS global network we talk about, that the local zones towards the region. It's basically, first of all, it's AWS's responsibility to extend that connectivity, which means that there are multiple redundant connections, physical connections, and when we talk about Trans-Tasman land, and multiple physical undersea cables going on between Auckland and Sydney itself. One of the question I saw and just to extend what Jason mentioned about moving towards local zone is basically, yes, you can have a direct connect co-location in Auckland, and there will be some benefit in terms of not having to bear the cost of the undersea cable, but at the same time you can opt for a multiple redundant connections by having one in Sydney and another in Auckland as well, to be able to connect to your workload all the time and not have a single point of failure.
Thank you for that. That pretty much wraps up the questions that we have. I think there was one more open.
Yeah, there's one.
Yep.
There's one that came in more privately, and it's related to the demo that you did. So the private VIV that you created that connect to the Direct Connect gateway, which you assume that's connecting to the virtual private gateway. So will AWS just simply determine whether you will go directly to the local zone or would it get routed to the region? Whether it's AWS team want to answer that. Like, do you make the logic to just go directly to the local zone from the Auckland on-ramp?
From Auckland on-ramp, it really depends where the target subnet is basically. So if you're connecting in Auckland DX co-location, at routing level, it's basically based on where the target subnet is. If it's in region, it goes directly towards the region using AWS backbone in this case. But what the customer is doing is connecting the Auckland on-ramp itself.
So that would be simply a more specific subnet that was created for that local zone than existed in the region.
Exactly.
Yeah, so great, because I think one of them is, I think the clarity around whether it's still connecting to the same virtual private gateway of the VPC, because obviously the local zone is part of the stretch. It's almost like a stretch VPC into Auckland. Probably the question is more around, do they need to then, is there another more specific virtual private gateway, or is this using the same one? I think you've answered it. It's just the same one.
Yeah,
but I think that's,
there can be only one virtual private gateway, one internet gateway per VPC, and logically they just take care of the routing depending on the target.
Cool. Thank you
Fantastic.
for that.
All right. I don't think there's been any other questions come through, but thank you again for everyone that joined us today. Hopefully that's been valuable. We do call these the Connect Over Coffee series. So if you haven't had one already, please go grab one. But we've enjoyed hosting you today. And thank you again to my team, Dave, who's in the background, Steve for assisting, and obviously our very valued and esteemed AWS peers that have been on the call today. So as mentioned, please feel free to contact us off list or book a meeting on there. We're happy to have a chat. But yeah, appreciate you joining today. Hope to see you again soon. Thank you.
Thanks, everyone. It was a pleasure.
Thank you.